Hello and welcome to this C programming video. My name's David Dawn. In this video we're going to be talking all about the difference between file descriptors and file pointers, because you may have a little bit of confusion at times whether something is a file descriptor and whether or not it is a file or whether it is a stream and so on. So let's just start by explaining this. We've got here a file path, and you can see here we've got this input.txt file to the side, and then we've got these three integers: standard in, standard out, standard error, and they are representing 0 or represented by 0, 1 and 2. Now you may have seen standard in or stdin and out and error. You might have seen it used, and that they are actually file pointers, all right? But right now we've just declared three integers. But a file descriptor, or mostly written by like FD and stuff like that, you'll see in function parameter calls. These are just normal integers, all right? But file pointers you will always see with like file, and obviously we haven't included the relevant standard IO library, okay? And just for the sake of clarity, if we come to the standard IO, we now have the file, all right? And this would then be a file pointer right here, a file pointer to a file. Now, what is the difference between a standard in, and when we look at, if we just comment these out now, and we just say fopen here, and we can see that then the file name that we need to provide, and then we need to then have the restricted mode, okay? And so we could then come here and say file path, and here we want to then just like read from the file, okay? And this will then create our pointer for us, right? So when we look at this, this returns a file pointer, but this is not a file descriptor. The file pointer, it refers to a file descriptor. Now, if we look at the likes of fwrite once again, we can write a specific message, and we could say file path size. We could then just say string. We could say size of char and number of items. We could just say string length is however many items are in there. So let's just say 5. And here you might say standard out, because you want to write the contents, or you want to write that string to standard out, which would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we would be writing 12 chars, bytes, to standard out. But as you can see here, that this standard out is referring to a file pointer within inside of standard IO. But if we want to refer to the actual standard out integer, when we want to use then write, for example, and write is a part of the Unix standard library here, and here we could then use the write, and here you can see that we've got an int file descriptor, right? Well, there's nothing stopping us from using the standard out here as well, right? And we could say then the buffer is then the file path, and the size, let's just use the use a string .h to get then the file, the string length, and we can say string length file path here, and let's just use the string length here on this one as well, right? And let's just close this down here because we don't need that. And when we run this, you'll notice that we get, let's just put a backslash on there, you'll notice that we get input text, because we've written the contents of that one char pointer to standard out, and in this sense we were using a file pointer, because that is then f is basically meaning a file that we are writing to, whereas write just points to a file descriptor. Now, does that mean to say that standard out, standard in and standard error are actual files? Well, yes, you may see on your system that they actually are a file, right? But they are only pointing to a number, right? In the end, they're only pointed to a number, and that number is referring to a stream. So it's not a standard regular file. This, however, this input text is a regular file that you can write to. Now, to show you how we can write to this one file using just the file descriptors or integers, we need to add the file control. Header, right? And this then provides us with then the open function, right, which would give us then the ID or the file descriptor of this one file path, right? So let's just say then this is then the file path, and with this one we want to then have read write permissions on it. Now, for the sake of Xcode, we're going to have to make this an absolute path for this example, just to work easier without messing around. And we're just going to take here and say C arguments here and take away the \n, and we'll just comment this out for the time being. All right, so now we have the absolute path to this one file instead. So we can open this one file up. We know it exists, so we're not going to check. Well, let's just check first of all. If ID is equal to -1, then printf the file does not exist. Yes, we could use p error here, but we're not going to, and we'll just say exit 3, for example, and we need the standard lib for that to work. And when we run this once again, you can see we want to have the desktop, and it exits with 0 because we know that the file exists. Okay, so now that we know that the file exists, we're going to have to close the file descriptor as well, just to be efficient. And let's place this down the bottom of it. Right, so now that we've got the file descriptor open, we can write a message to it, and you can see right now it says hello world from input text. And so let's just come here and create a message here, and we'll say this is the new text. All right, and we'll put a \n on it. And so now we can come here and say write to the file descriptor, which is then of the ID that we have, right? And we can say the message that we want to write to, and we'll just say that the string length of that is then message, and then we close the file, right? So when we run this, we access the desktop, whatever, and we look at the file and we say this is the new text, right? This is the new text, and it only wrote the information that it had, you know, because it had other information in there before, which meant that it didn't write over the input text here, right? It didn't clear the file completely, all right? So when it opened up the file, it's not like it just destroyed the contents of that one file. It said, I'll open it up, I'll set the pointer at the beginning of this one file, and then we wrote those bytes to it within the \n for the new line, and it went to the new line. So it just overwrote the data in that one file. Right, so this goes to show you how you can now do it with inside of the write. And so let's just say here, hello world from the input text here. We'll say that back again. So this is how we can do it with the write. Well, now that we've done it like this, to do it with the fopen, we would now have a file, right? And we'll just do the ID here. And if ID is equal to null, this is now a file pointer, and the last example was a file descriptor. Now, to do this like using as a file descriptor, we then have to say using fwrite, or if you still wanted to use write here, we would just then say file number, and here we would then say message instead. And let's just take this text out so I don't have to write it again. And when we run this once again, you'll see that the application, oh yeah, obviously we need read plus here instead, and then the program ends perfectly fine. All right, and we can see now this is the new text. All right, and let's come back and just place this text back in there again for future examples. So you can see here that we can use fwrite. So we can use a write using the file number, but still using file pointers. And if we now use fwrite instead, we can just say ID straight away, and the size is then size of char, right? And then we can say string length is the amount of bytes or chars that want to be written to it, and message. And now we can say, sorry, this is then the message that we want to write. And at the end, we then say the actual file pointer itself, so not file descriptor. And we run this once again, we get access to the desktop, and we look in the file, and we see this is the new text. And let's just put this back again. Happy days. Okay, so this is basically the difference between file descriptors, right, which are just integers, and file pointers. And then we can go ahead and say what is the difference between a file descriptor and a stream. Remember that standard in, standard out are streams. They are not files. They might be a file on the system, but that doesn't make it, they don't have the same characteristics as a regular file. However, when we use open, we are opening that file to be a file descriptor, all right? And then in the background, the system is working. It works with it differently when you write to that one file. Okay, so inside of write, it knows that when it has a file descriptor, whether it has a buffer to read to or to write to, and so on. Okay, but I think that's another video. With that said, I hope that you've got something out of this video. It's really important that you understand the difference between file descriptors, file pointers, and also streams, because when you start wanting to work with the likes of, let's just say that you have a microcontroller and you want to talk to a sensor, and you want the sensor to talk back to you, you transmit on the, you send data down the transmits on the microcontroller, and that then is then attached to the receive on the sensor. And then if you want to then send data on the sensor back to the microcontroller, it sends it on the transmit, and then it receives it on the receive on the microcontroller. Obviously, they have their own paths to write upon, all right? But when you want to start talking about being able to read and write using the same file descriptor, that's where the likes of write will check to see whether or not it has a buffer for the read and the write as well. But I've just explained that in like about 25 seconds, which is not correct. Okay, there's a lot more details in it than that. So with that said, I hope that you've got something out of this one video. If you did, don't forget to like, subscribe and share, and do all of the other social media things out there that you can do. So as you can see, I've recorded this video, or am recording this video on the 25th of September 2024. This video is going to be released on the 1st of October. And it, basically because I batch make videos at a time, and I release a video on a daily basis at 12 o'clock every single day, Central European time. If you want to be able to access all the videos as they come out without waiting, you're more than welcome to become a member. You obviously don't have to. Just by watching the video all the way through to the end is already enough support for me. But if you feel that you really want to watch all of my content, and there is content on there, then it's down to you whether you want to become a member or not. It would make a big difference to me, not financially, just it would make a big difference to me knowing how much people feel about my videos or about my channel, or about maybe my learning style, my teaching style. So with that said, if you do, then please feel free to do that. If you don't want to, then that's perfectly fine. What about just if you've got any questions, feedback or concerns or critiques, then let's start a conversation in the comment section down below. I'm always willing to hear your opinions. Other than that, thank you very much for watching. Thank you for watching all the way through to the end. My name's David Thorne. You've been watching David's videos. Thanks very much. Ciao, ciao, and goodbye.